Oh, yeah. Finally, I got it. Sorry about that. Thanks for your patience. I'm going to introduce myself again. I'm Vania Hanatiuk. I'm a Woman Techmaker Ambassador and chapter lead of GDG Cloud Edmonton. We are GDG Cloud Edmonton, an official chapter of Google's worldwide network of cloud enthusiasts, developers, data scientists, and engineers. Our team is integrated by Rohan Saha, NDD Obingwani, Tevitope Ahiboyi, and Devipriya Raju. Our community is built by 847 members with 1906 followers on LinkedIn. We have hosted technology events such as Cloud, Flutter, and Machine Learning Study Jams, our famous DevFest, this edition of Google I/O Extended, hosted more than 10 community events, and our favorite one is the International Women's Day, and collaborated with multiple local developers groups such as University of Alberta, CSGSAA, Women in AI, and Canada Learning to Code Edmonton. Before to start, let's do some housekeeping. We are committed to providing a friendly, safe, and welcoming environment for all, regardless of gender, sexual orientation, ability, ethnicity, socioeconomic status, and religion, or lack thereof. Participate in an authentic way. In doing so, you contribute to the health and longevity of this community. Exercise consideration and respect in your speech and actions. Attempt collaboration before conflict. Refrain from demeaning, discriminatory, or harassing behavior and speech. Be mindful of your fellow participants. We would like to acknowledge that we are based on a traditional lands refers to as Treaty 6 territory or Turtle Island, a traditional meeting grounds, gathering place, and traveling route to the Cree, Saulteaux, Blackfoot, Métis, Dene, Nakota Sioux. We acknowledge all the many First Nations, Métis, and Inuit whose footsteps have marked this land since time immemorial. Before to start, let us tell you about Edmonton for people who are joining us from far from here. We're just a little bit north of the planet. We are located in the capital of the Canadian province of Alberta. In the picture, you can see one of our iconic landmarks, the Waterdale Bridge. We are home of the NHL hockey team, the Edmonton Oilers, who made it to the Stanley Cup final this year. Additionally, Edmonton is considered in the top 10 of cities with best pizza, where important pizza restaurants chains were founded like Boston Pizza, Famoso. And lastly, we are north enough to witness the stunning Northern Lights. This will be the program for this morning, and let's start with the first talk, Unlock, Maximize, and Leverage Your Cloud Skills for Data, AI, ML, and Security by our WTM Ambassador Phillippa Burgess. Next, we're going to have a technical talk, Basics of Large Language Models by our VP Rohan Saha. And at the end, Immersive Art with Generative AI and Intelligent Captioning with Ravimbe Kerenjain. And at the end, we're going to have some contest and a farewell. We're going to start with a talk that we hope you can get the best learning resources from it. This talk is prepared by a very accomplished lady who is a graduate student of a Master in Science in Human Security and Geospatial Intelligence at the USC Spatial Science Institute. She's a Woman Techmaker Ambassador who is leading the Cyber and Information Security Awareness WTM-led mentorship, a program which mentors women who are starting their careers in cyber and information security. She hosts a podcast, Muse and Metrics, and before her extensive career in tech, she worked in Hollywood. I'm excited to introduce you, the one and only Phillippa Burgess. Hey, Phillippa, how are you doing this morning? Thanks for
Hello, wonderful. Thank you for having me. Great to see everybody here today. Obviously, this is Cloud Edmonton, and so we're talking about cloud. So I imagine many of you also come with cloud knowledge, and so I want to make this as interactive as possible to lend the most value, but also create it as beginner enough that someone who is entirely new to cloud is completely welcome here. And Vanya and I were together as Women Techmaker Ambassadors at Google I/O this year. We both have our shirts, and yes, we have our matching swag shirts. And one of the things that I'm going to share is something I specifically learned speaking to the cloud team at Google I/O. So it was not something that I found any other way. And actually, two of the things I'm going to share because we're going to talk about Notebook LM as well. I learned about the year before at Google I/O. So we are a Google I/O extended event. So here to bring you some of these insights and announcements that they make at the show that we can sort of take with us all year long. So with that, let me get my presentation started. If it's okay, I'm going to do sort of a math screen share, meaning you're going to follow my entire screen. We're going to see if this works or not. And I say that because I'd like to make this as interactive as possible. So yeah, so okay, so you have my presentation. So
yeah.
hopefully you can all see that. But then we can actually go into the console. We can look at the various paths. We can, actually, I'm supposed to be in Innovators. We can actually see where I'm going to show you where you can get learning credits for free. You get 35 each month, though they do expire. We're going to hop into Notebook LM. And so there we are. So I'll give you that. And so, yeah, so here to talk about how to unlock, maximize, leverage cloud skills for data, AI, ML, and security, and all the things that cloud does. I am happy to call myself a Google Cloud advocate, and my credential to do so is having become a cloud digital leader. So I'm Google Cloud certified, and I am on track now to learn, be part of a launch pad for to become a Google Cloud architect. And then I'll continue sort of adding the data and security pieces as I go. One of my goals is actually to become kind of a Google geospatial expert, since that's part of what I study is in spatial sciences. So yeah, just a little bit more about me. Again, being that Woman Techmaker Ambassador, it's an amazing community. Definitely invite women to be members of it. You can do that at womentechmakers.com. And then every year they invite applications to be an ambassador, where you speak, you lead your communities, as exemplified by Vanya and all the work she does. And so cloud is obviously a foundational in the work that I do because there's just so many resources available there. I just recently finished on the Microsoft platform a spring project as my role as a Microsoft Student Learn Ambassador, doing AI and machine learning for satellite imagery that we built our machine learning model within the Azure AI cloud. So that's the nice thing about cloud is once you start, whether you're learning Google Cloud, the skills are incredibly transferable to Azure AI and to AWS. So that's what I really like about once you start learning, all of the knowledge builds on itself very quickly. Same thing with coding. Like as you start learning one language and how to work with IDEs, you can very much continue to learn other languages pretty easily. And then I do a lot, sort of in the geospatial space and also in the security space. Specifically, I have a master's in urban planning. And in that program, I fell in love with the data science piece and the fact that I could make pretty pictures with data and then I could actually make maps. I was like, ooh, tell me more. So I continued my studies with GIS, and then that was just a starting point. And I was like, I think I need more. So I ended up doing this second master's in human security and geospatial intelligence. But I'm only now qualified for internships that require 1 year lead time because they all come with security clearances. So I'm actually going through my application process right now with NGA, so in the United States, for the National Geospatial Intelligence Agency, NRO. So a lot of my work is also intersects with intelligence, and that's what led me into cybersecurity. So I'm also doing a certificate at the law school in privacy law and cybersecurity. So that's just a little bit about me, gives you some context for just my kind of perspective and role in coming to this. And so I'm a student, and I think that's part of the like what I want to share with you is because as a student, I do find it easy to learn, and I'm always taking on learning. And I think perhaps sometimes we take breaks from learning, and sometimes it's a little harder to get back into it. And that's why I think finding communities, obviously you're here, so that speaks a lot to your desire to learn, to connect, to build community. As you want to learn this stuff, it's not hard to put together a study jam so that you don't have to do it entirely by yourself, although everything is set up for these sort of self-learning paths. So whether you do it on your own or you do it as a community, all of these resources are available and there for you to use to learn. So why cloud? It's scalable, it's flexible, and it brings a lot of cost savings. And there's definitely value to upskilling for current and future job roles. So these things are great for you to know and use, but also look really good on your resume or just things you can add to your current roles and workplaces. Just want to bring you some of the top cloud computing statistics. So by 2025, there will be 200 zettabytes, a trillion gigabytes of data in the world. By 2026, the cloud computing market is forecasted to be worth $947.3 billion. Not here to give stock advice, but just from my own portfolio, I will tell you that the stocks that I bought in Google and Microsoft keep going up. So I definitely see that the cloud AI revolution is here, and I also have NVIDIA and a couple of those other ones that are doing quite well because I feel like that is going to be defining not only our present but our future. Here it says 96% of companies use the public cloud. AWS does remain the biggest cloud provider with 32% of the market, and then of course you've got Google Cloud Platform and Azure, and then 84% of companies use the private cloud. Main challenge facing cloud decision makers is managing cloud spend. So that's something you've got to kind of figure out kind of how much all this is costing. But what's really valuable for companies is the scalability and the flexibility factor so that you can scale up or down as resources are needed, as opposed to kind of on-prem infrastructure. And so it really depends on kind of what the needs are for the company. So basic foundation of cloud, and this might be familiar to many of you. And if it's not, I'm just going to give you just kind of the reminder. And if something here is familiar to you, think about these as talking points that you can own for yourself to share with others, because these are sort of foundational as you start to speak about cloud. So the understanding of the infrastructure as service, platform as service, and software as service. So the software as service is for the users, platform as service is for the developers, and infrastructure as service is for an IT-centered business. And with all of that, there is a shared responsibility model. So in a users-only environment, that responsibility is going to be held by the cloud provider, whereas when you're at an infrastructure, that most of that responsibility is going to be held by the business. So when you're talking about cloud, those are kind of just the basic idea of what are you buying, or which parts of the cloud are you using. And then again, more on why cloud. And it's a really exciting time for it. It is growing rapidly. And the thing is that the companies are very motivated to teach you to use it, because if you don't know how to use it, you're not going to optimize it. And then you're obviously not going to either manage your spend well or get the most for your money of what's possible for you to do with it. So that's why these learning resources, many of them are free or very cost effective. And I'm also going to give you kind of the discount of how you can get learning credits every month with cloud to kind of continue. But you will find that all of these services are very, very motivated to work with you to make sure that you know how to use them so that you can make the most of them and put it to work in your business. So obviously it's huge for data. And, here's they're just talking about putting data to work. And obviously a lot of AI and ML is built on the cloud. So they've got 900 partners and software integrations within the Google Cloud data ecosystem, 135 languages translated with just a few clicks in Translation Hub. More than 70% of generative AI unicorns are Google Cloud customers. and over 110 terabytes of data per second is analyzed by BigQuery customers. And that then goes to the next line, which is security. And cloud has security built in, but it is a partnership. So it has to be managed by both parties to make sure that cloud is secure. And obviously, when I deal with security is never perfect. It has to be kind of a good enough. So, companies do have breaches all the time. And if a breach does happen, they are saying 1,800 organizations get back to business quickly every year post-breach, which is, again, a small number relative to how many people use clouds. That 40,000 vulnerabilities found by Google in open source software projects, 6 million sites protected by recapture, and 9 billion files and URLs analyzed for threat observation. So they have a frontline intelligence with Mandiant, which is a partner. So we all need to be cybersecurity aware. As Vanya mentioned, I'm leading that mentorship, and I just think that it's really important that people don't say, oh, yeah, I have a cybersecurity team over there and they deal with it. Like, every single one of us needs to be cybersecurity aware and conscious that there are threats out there, whether it's just internally not having the right processes and procedures, or protecting ourselves against threat actors. So cloud comes with a lot of those security measures in place. But again, everybody's responsibility, and they're not perfect systems. So just being clear about that. So that's just kind of the foundation of cloud. I'm going to come over here and stop sharing for just 1 second, just to sort of see if there's any questions, because now I'm going to move over to the certificates and certifications. And then we're going to move over to our notebook LM demo. Okay, so hello.
Don't be shy. Hi. Don't be shy. You can enable your audio if you want, or type us in the chat if you have any questions.
Oh, sorry, my voice. I was going to say, I don't see any now, so I'm going to go ahead and continue. And if you have any, feel free to pop in the chat, and I'll come back and look after this next section that we'll go through. So we'll do another screen share. Okay. So just want to clarify the difference between certificates and certifications. Certificates can be anywhere from a university to a Coursera course, or many of these learning paths end with a certificate. And then the certifications are actual proctored exams. I've done both in-person and online ones. And the online ones, you have to download specific software, and then you have to have a camera that sort of does a 360 of your environment and show the four corners of your desk just to make sure you're not cheating. And so they're very different in that way. So even if you're in a hiring position, if you're looking at the difference between certificates, it's good that people get them, but certificates are not created equal, whereas certifications are skill assessment, and you're going to see kind of that this person does know this. And also will say, as they're not also created equal, I'll often use ChatGPT or Gemini as I'm going through certificates to just facilitate going faster, learning more, not getting stuck on things, and just kind of moving through. And I think that how you use these LLMs, and you'll talk more about that in the next section, can be very helpful. I use them as study guides all the time to organize my thinking, to help me understand more. I just move through them very quickly. So as I do a certificate program, I feel very comfortable with that, because to me, the certificate is there for my learning journey. And if I learn faster using an LLM, that's my choice. A certificate, I will not cheat. You're not allowed to cheat. You can't bring any help with you. So when you're sitting in those exams, you have to be focused, and you have no extra things distracting you. And it's really just what's in your head. What I will say is that once you get going, it moves really quickly, because and I say move really quickly. So for example, I just did a certified in cybersecurity, and I did the digital cloud leader exam within the same week. 1/3 of the digital cloud leader was cybersecurity. 1/3 of the certified in cybersecurity was cloud. So there was a lot of crossover, and that really is helping me. So I'm now doing the architect program, and I'm still seeing that it all the information is starting to stack. So sometimes I do feel like I'm going in a lot of different directions, and then other times I'm like, no, it's actually all the same thing. It's all working together, and it's all increasing my knowledge and grounding it, because a lot of it does get a little bit repetitive, not in a bad way, just in a way you can kind of move through it quickly and sort of check the box and be like, okay, good, I'm comfortable with that. I know that. Um, and so, like I said, these companies are really motivated for you to know this. So they have all of these learning paths, all these different certificates that you can do. And there's different organizations that will sponsor vouchers for the exams. Some of the exams in other associations, like for example, my cybersecurity, there's an annual fee, and you are required to keep up your training with additional credits. Whereas these, it is good to kind of keep going and kind of keep building, because it will start with a very foundational, and then you can sort of niche into different things. But then again, you start seeing there's a lot of overlap between AI and ML and data science and cybersecurity. And so you can feel free to just follow your interests wherever they may lead. So what is this learning platform? It is Google Cloud Skills Boost. So we'll take a look at that over here. You can see some of my work and interests. So I'm interested in the cloud learning, DevSecOps, database engineering, security. So these are just ones that I've sort of marked as um, my interests and things that I kind of want to have next. Also, these are sort of learning paths. I've got Google Cloud Computing Foundations, fundamental security principles, and feel like there it is. Okay, and then they have little leaderboards. They make it fun. They kind of gamify it, so you can see that I'm in the top 3. But that is only because I just finished. Make this a little larger so you can often see it. I just finished a learning path that was part of a voucher that they wanted me to finish some prerequisites before I would qualify, which I think was good. They wanted to sort of say, see that you're on your way. Okay, so you can see those being a bit larger. And then these are the paths. Okay, so you have many, many paths to choose from. You really can start anywhere you want. A learning path will have multiple modules, and then the module itself are just kind of the smaller bite-sized pieces within. So you can see that I finished this one. That's why it's greened out. And then I think somewhere over here they have, then you get a public profile, and then also so here in my public profile, you can see how many points I've earned going through these, and then which ones I've just completed. So as part of this upcoming Google Cloud Architecture Launchpad, they asked me to complete the infrastructure core services, the cloud foundation, and the fundamentals core infrastructure. And before that, I had done some of these other security ones, and then of course I've done AI, data. So you can see kind of my own sort of learning paths there. Okay, so you go to cloudskillsboost.google to get started skilling up on cloud. You will find that many of those paths are free, but if they're not, I have the way forward for you there as well. But this is where you go to Cloud Skills Boost, set up your profile. You can keep it private, you can make it public. I think it's good if you make it public. You can kind of add badges and just kind of show your progress. And then these are kind of what some of these are going to look like. You can see on the side, they're going to have the little modules. They have labs as an example of a lab where you put it into an incognito window, and then you work through the actual platform itself. And I find them very useful. I will say that I tend to go through all the videos first and then go back and do the labs later. That's just how I do it. You will see that it is your own thing, and you'll find how you learn and study best. Now, this was 5 credits, and that's where I'm talking about. Not all of these are free, and because the labs actually take cloud resources, they do charge you for some of these. So that's where you will use your cloud credits, and that's where we'll go get your cloud credits next. at Google Innovators. This is what I learned at Google I/O. When I talked to the cloud team, they said, yes, you can get 35 free learning credits every month through Google Innovators. And so you set up your cloud profile on Google Cloud Skills Boost, and then you come over to Google Innovators and you register and you claim them. Now I can't quite tell because it says that I have 105 credits, and yet I also got a notice saying that my credits are going 35 of my credits are going to expire this week. And so I don't know which ones kind of are retained and which ones expire. I've never hit my limit more than I'm able to learn at this time. But there is also a subscription I could buy, either on a monthly or annual basis, if I did want to go further faster. But again, with these free credits and what is also already available for free, I haven't hit that limit yet. And so in order to claim your credits, go to cloud.google.com innovators. And then we're going to get over to our notebook demo next. But before we do that, I am going to just jump us into the console real quick, just so you can see inside of the cloud. So here we have a project. So here's kind of all the resources of what you have. So you've got your APIs and services, billings, identity management, marketplace, compute engine is where you can kind of create your virtual machines, Kubernetes, cloud storage, BigQuery for data analysis, VPC network. I know on all of the labs I did, most of them, you jumped right into VPC networks, Cloud Run, SQL, security, Google Maps platform, Google Cloud setup. So I remember doing a project that was I was working with 3D tiles, and it was part of actually a Google Immersive Cloud hackathon, and I tried working with cloud without any training, and I failed. I realized that I was like, okay, this is beyond me. It's just not doing what I want it to do. And now that I've gone through this training, the things that I had wanted to do then, I can easily do now. So you can go through this on your own, and you may already kind of have some skills to get started. But I would say the trainings are totally worth it, and you'll just learn things that you didn't know that you will find rather useful, I would hope. So I do recommend these learning paths and the labs. They are very practical. They're very hands-on. Like, for example, when we were doing a lot of the VPC network stuff, let's see if I have it in here. Oh, okay, we'll go back. That's not. I'm not in a lab right now, but they have where you can open up the shell, and so they show you kind of how to custom code a lot of the stuff. And so just, anyways, good tools. So I will now come back over to our session over here. Hello, everybody. Oh, great. Vanya has shared that where you go get your the Cloud Skills Boost, and then let's also share that that it's the Google Innovators is where you get your credits. You can just Google that. So I'll put that there. Excellent. Okay. So are you all ready for Notebook LM demo next? I will bring us over there.
Yes.
Yay. Okay. So as it turns out, I'm doing this mentorship, and I ended up doing my mailing list through a thing called Tailwind app, which is not what I intended, but because when I actually heard about it through Google I/O 2023, it was originally called Tailwind app, but apparently a different company had that name. So I was like, oh, well, that's interesting. It's a marketing tool. So I ended up using that one, and then had found out that at that time when I was looking it up, they'd actually changed their name over to Notebook LM. So now I use both. Notebook LM let's get back to my share. We're going to jump in. It is a little messy and a little awkward, I will admit. I had considered, I was like, do I go ahead and like pre-record this section to make it really clean? And then I was like, no, we'll go live and we'll give it a go. So this is Notebook LM. It's notebooklmgoogle.com. And you create your notebooks. And what I love about it is, you can see that I've created a few, is that this is actually, I'll start with this Port of Long Beach project that I did. So I was talking about actually that one that I was doing 3D tiling. It's a company called Cesium, and I wanted to look at a ton of reports about the Port of Long Beach. And here, so what you're doing is you're uploading all of your PDFs that you have related to a certain topic, could be, and then you have the option to toggle them on or off. So maybe you have a couple different topics and you're like, okay, I don't really want to talk about those just yet. And then it will give me prompts for what is in the data that it sees. But let's ask about port cargo volume. And so now it's looking at all these reports and it's seeing what it can come up with that it can find. And there we go. And everything is cited. So if I wanted to put a presentation together, especially when I want to cite data, but I don't want to just have to manually read all of these documents, which range from 3 pages to 400 pages, I can go and, just like I said, ask it a question. So now we know that the Port of Long Beach is the #1 loaded export container seaport in the U.S. as the second busiest seaport. It handles $200 billion in trade. In 2018, it handled 8.1 TEUs, which are the containers. In 2020, handled 1 million metric revenue tons. Anyways, the idea is you can see, and then each one of these is cited, so you know exactly which document it came out of and where it was in context. So I find that this is just super helpful if you're doing research, if you're studying, if you're doing any kind of report, if you have a lot of information on a particular topic and you just, again, want to jump in and say what's here and help you sort of parse it out and source through it. Now, this is not going to be helpful if you want to now turn this into an article or a blog. That's where I copy this, and I got a little copy right there, and I can then bring it into a Gemini or ChatGPT to help me turn it into actual content that I would use. But in terms of a research, now all of this came without these additional ones because I toggled them off. I don't know if there was anything in those specific ones, but let's try it again, and then we can see if it pulls up anything new or it's going to be the same. But you can definitely see that it takes a minute because it's going through quite a bit of data. And then it's also, yep. Okay, so now when we toggle those other ones on, you could see that it comes up with a bit of a different answer because it had new data to draw from. So again, you can toggle those on and off, and that is talking about the different types of cargo. And now it's going to give you different prompts based on this. Again, so you can go in a new direction. We can ask about environmental initiatives. And then you can start saying, like, how does the Port of Long Beach geographic location contribute to its vulnerability to climate change, analyze potential economic impacts. So it gives you prompts based on the data and the kind of questions that you're asking it. So it can kind of help you go further. And then it has options. Okay, so here we go. So we're asking about what were some of the environmental initiatives. So then it talks about these different various initiatives, and it's got quite a few. And again, every single one of it is cited, so you can know exactly what was that, where this came from and the context of it. So if you're writing a research paper, it is super helpful. And you can this is where it says it's experimental because there. If I want to create a new notebook, you have options of where you're pulling your files from. And then you kind of add them, and then creating new notebooks is if you want to sort of save certain chats and certain things, you can save them in there. So that's I will now come back over here and see what questions. Do we have any questions about this? Does anybody see an application in your own work or studies, or just ways to learn faster?
Are there any other features in Notebook LM or other tasks that you can do with these PDF sources?
I'm going to say Notebook LM, it's very basic, but it is deep in terms of once you have your data and you just want to parse through it. Because again, I think we're going back to the, hold on a second, let me get my screen share back up. And that's a great question. Thank you. Go back to sharing my screen. Let me just go back to some of the slide presentation I had on this. So again, yeah, you toggle your PDFs on and off. What's different about this than, like, I use ChatGPT all the time, and in my ChatGPT, because I have the paid version, I can attach files, I can attach screenshots, and that really helps me because it can see what I'm seeing, and it's really good for troubleshooting because I do a lot of maps and working with a lot of software with cloud. And again, with those labs, oftentimes I will use an LLM like ChatGPT or Gemini to help me troubleshoot things that are just not as obvious to me. And again, I wouldn't do that. You can't do that when you're taking an actual exam, but when you're going through your own learning path and your learning process, for me, it just makes it easier for me to not get stuck and not feel like I'm struggling and just to move quickly through it. So that's where what I like about Notebook LM is you're really able to add so many PDFs. Like I think when I first started using it, you could only do up to 20, and I think now you can add 100, and that's what makes it different than other LLMs is just the volume of data that you can put in to analyze and source through and ask questions about. Uh, and then again, you can follow their prompts for additional questions because it already sort of sees kind of what you're asking about, and it sees where there's additional questions that it can answer for you. Now, sometimes you will ask it something and it will say, I cannot answer. I do not have that information. Again, all of those replies include citations. So it makes it really great if you're writing a report and you have to add those footnotes. You can save the notes as needed. But I do recommend that Notebook LM is really good when it's integrated with a Gemini or a ChatGPT. And since it looks like we have a little bit of extra time, perhaps, oh, actually, little things. If you didn't already know, you can create a theme with AI, and I happen to pick a watercolor forest, but you can customize your Google page. And I was going to come over here and just show us the Gemini, and I'm sure Ella, the next session will give us a lot more insights into LLMs. But again, I definitely use this quite a bit, and again, you can use them sort of together. And but I will say I'm still a little bit more on ChatGPT because I just use it all the time for everything. But again, our next session is going to cover that more. So I'm going to say, okay, so we've got cloud, BigQuery for data analysis. There's a lot with security that you can get into. Again, managing your billing is really important. Compute engine, again, you can launch virtual machines. Cloud storage is really important because you can get things into a shared environment, and then of course the identity access management administration is really important in terms of who can access what. And there are so many APIs and services that you can be pulling in. So there's just a lot here, and I just encourage everybody to go and play and get started with these learning paths and what's available on them. They're a lot of fun. They move quickly. Sometimes actually another hack that I have, if you're going through a lot of these things, some of them are video based and some of them are text based. So I use Bing. So one of my favorite features, and again, being a student, is being able to take a PDF that you have and just hit read it to me. Now, my family's British. I think I have the British guy. Let's see. What to do? This is not working. But sometimes there it is. Here it is. Certification exam guide a cloud digital leader can articulate the capabilities of Google Cloud core products and services and how they benefit organizations. It can also describe common business use cases and how cloud solutions support an enterprise. This certification lists Okay, so with that, you have voice options. So you can choose your accent. You can so these are English, but with this kind of any kind of international accent that you want to go with it. So that's why I have. And then you can also choose your speed. So I go with a super fast because I always want it to go quickly, and I'm an auditory learner, so that's really helpful for me. And then you can go to normal, or you can go slow, whatever works for you. So, for example, I'm also doing the Google Coursera, and they have a combination of videos and text. So I always run my Coursera in Microsoft Edge so that any of the written stuff I can just hit play and just have it read to me. And that's just again one of the things for how I learn. And so that's one of the things I would recommend to you as well. So here we are. Okay. Questions, comments? I have a few minutes before you guys will transition to the next session. I hope this is helpful.
Yes, for sure. Thanks for sharing your powerful study techniques, and also this quick walkthrough of Notebook LM. Because you show it to me, I have used it for like my own study applications as well. And I was very excited to invite you to show our community Notebook LM's capabilities.
Yeah, and it's super simple. Like I wish there was more to it, but but it's so useful if you're doing any kind of research because it's going to do it in a way that Gemini and ChatGPT just can't. As far as like they don't always give you all of the citations, and they're good at manipulating it. Like I said, if you want once you cut and paste it in, and you say, "Hey, turn this into a blog," then you will get that kind of stuff. Oh, hey, and we've got the maps. So I study map making. So this was such an honor when I was invited, and I didn't know what they wanted. They were like, "Send us a photo and a bio," and I was like, "Okay," and some of your projects. And so they shared this. They created this, and Vanya, I'll let you talk about it
Uh,
from here.
yeah, because we want to have the top of the crop of our Google developers ecosystem community. As we can see, Phillippa is highlighted in this feature of Google Maps platform. This is a interactive map where all the most famous and accomplished women makers ambassadors. Here's what you can see in this map, because maybe I'm sharing it now. It's like freeze, but if you check this link by yourself, you will find all the woman makers map here. As I say, Phillippa is right here.
Yep,
Let
I'm the
me,
San Diego lady.
yeah, one moment. I'm just trying to, oh my God, one moment. I'm just going to share it again. I think because I share, it freezes.
Yeah, and while you're doing that, I'll share one more thing really quickly, just because I think this will give a little bit more context once you're.
Yes, for sure. Are you going to share?
Yeah, if you well, you can finish what you're doing.
No,
Okay.
the screen is for you.
Okay. I mentioned it a couple of times, and so I wanted to talk about um, custom coding. Like I don't know, everybody's at a different level, but I just want to sort of say, if you're just getting started on your coding journey, back to using all of these tools can be so helpful for you because I knew nothing about coding in JavaScript, and this is a custom app that I made about this Port of Long Beach project. We just looked at sort of what I did with Notebook LM, and now I want you to see kind of where the result is. So this was custom coded in JavaScript. Remember, I was saying the first time I looked at Google Cloud, I failed at it because I was literally my project. I was trying to figure out, like, well, how do I host a static web app? So I decided at that time, I was like, well, I'll just host it in GitHub. But my goal was that I could host it in Google Cloud Platform. And so now I've been able to do that. But here's what I did is I just wanted to have these little slides that show and tell the story about the Port of Long Beach as a green port. So all this slide data was pulled originally from Notebook LM and then kind of modified and made ready for presentation with ChatGPT. So I could pull in these stats about 36 billion annual economic activity, handles 200 billion in annual trade volume. We already saw that when I did the notebook LM. And then this project's almost done. I just need to make these kind of like data points prettier. But this one basically takes the map of the port and then just talks a little bit about more of like what the different terminals are and what's contained there. And then I'll go quickly through this. But the idea here is that this is like a 3D model and you can kind of see around the port. And then I did pull in, this is actually where I was playing with bathymetry. So this one kind of goes underwater. And there we are. But all of this information about the environment, the mudflats, the fish habitats, the migratory routes, all came from working with Notebook LM. So this just give you like a very, that's coming out under the water. But also when we talk about cloud APIs, this is actually where I was able to put in a real-time air quality API. So we can toggle that on or off. It actually does the most value on this one because you can actually see the United States and North America in terms of real-time air quality. And I believe we have quite a bit of fire going on over here, you can see, so not good. But this is real-time. So those are those APIs that are available through the cloud platforms that I was able to put into this project. So this is working with cesium 3D tiling, but that just gives an example of why I was using Notebook LM and how it was just really helpful for me to get all of this kind of data to put into my narrative here. And that's it. I'll leave that. Okay. Okay, so I see Roshan, you asked, you have 0 credit. How do I get that 35 credit? So I'm going to get back to my, I think actually you tagged it, right? You tagged it in the chat, Vanya?
Yes, in the chat, I have just shared a second link that lets you to join to the Google Cloud Innovators program.
Yes.
This program will get you free credits to access to those Cloud Skills Boost. So
Yes.
in order to have access to Cloud Skills Boost learning paths, you first need to join the Google Cloud Innovators program that will get you those 35 monthly credits.
Mm-hmm. Yep. So that should answer, Roshan, should get you those credits. So yeah, go ahead and create your Skills Boost account. And then go ahead and when you go to Innovators, you'll connect that. And then they'll you claim your credits. And then monthly you will, I don't know if it's infinite or how long they're planning on running that program, but it's live now. And I definitely recommend it because it's free. And as we've kind of hopefully I've demonstrated, you know, upping your cloud skills boost and your coding skills wherever you are is very possible and very easy with all of these tools that we have available. Again, what I just showed you is, yes, you could claim your free credits per month, yes. What I just showed you that I coded in JavaScript was literally all written in ChatGPT. That was me not knowing how to custom code. And I would just kind of ask it, what do I need to do next? How do I program this? What do I do? And so that's why I feel like as you're going through these learning paths or you're actually doing projects and you're getting stuck, like do not hesitate to use LLMs to just help you move faster through things. And I find like the best tip that I have for learning is just approach it with joy and don't get frustrated and use any tool in your ability to always continue approaching it with joy. And I think that's where being able to learn tech with the assistance of LLMs, ChatGPT, Gemini, Notebook LM has just made it more fun. And so I'm able to do more and find it to be enjoyable. Whereas if you get stuck, it's just so easy to give up and just be like, this is too hard. And also with community is the other part of it. Like you don't need to do any of this alone. You can find people and collaborators who can study with you, cheer you on. Like you're here, and a big part of being here is just building community. And to me, like the secret of where you know you're part of a community is where the people you know each other. So you're not just building one-on-one relationships, but you're part of a fabric. and that fabric will just carry you further. And with that, I think I can kind of yield the stage. Happy to answer any additional questions. But hopefully, everybody's gotten some sort of insight into cloud and your ability to access it, leverage it, uh, and look for the not only those learning paths, but those exams that you might want to be working towards, because that's really where you show that these are. Um, I'm going to do one more screen share. That this is the stuff that you know that's actually the real skill assessment. So I was just going to just finish out my slide presentation here. So we've got that notebooklm.google.com. So check it out. And then I just want to thank you. My podcast is Muse and Metrics. It airs on 360 Talk Radio for Women, but I do the replays on Google. I'm still learning Google and editing and not Google, YouTube, which is owned by Google. So I play with YouTube, but you can find me there, Muse and Metrics, Phillippa Burgess, and then another one that I'm kind of just starting to launch more is this maps data design, which kind of takes in a lot of my geospatial learning and my love for data science. And so now I will stop sharing. And Vanya, I yield the stage.
Yay! Thank you so much, Phillippa, for this insightful talk. And please, I invite you to clasp or applause Phillippa in the chat. She have given a great presentation. Thank you so much, Phillippa, and enjoy the rest of the weekend.
Yeah, I'm looking forward to it. Thank you so much. Appreciate everybody here, and I'm excited to see what you do with this information to take you all to the next level.
Well, thank you so much, Phillippa. And now we are going to go to our second talk. Just give me a minute. I'm trying to to keep Now we are getting a little bit technical with the following session. We'll dive into the fascinating world of transformers, explaining their inner workings, especially the attention mechanism that makes them so powerful. This talk was already presented at Amy's Upper Bound conference this year, so we got you covered. Basic LLMs was prepared by my teammate Rohan Saha, who is a PhD student at the University of Alberta with a research interest in improving language models in common sense reasoning tasks. Rohan is an enthusiastic educator and is dedicated to sharing his knowledge with others. Equally important, he is the VP of our organizing team of GDG Cloud Edmonton, where he has supported the operation of our events and been a liaison with other U of A's community association. He has also hosted other technical workshops with us, like the machine learning and cloud study jams. Beyond his academic pursuits, Rohan likes to try new recipes and makes delicious banana bread that I hope he will bake for our next TED Fest. Please welcome with a great class, Rohan. Yeah, Rohan, we are waiting for you.
Yes, I think you should be able to hear me. Okay. So I'm just gonna quickly share my screen. Let's see.
Yeah, now the screen is for you.
Okay, yeah. Okay, so you should be able to see this. Cool. So good morning, everyone, or good evening if you're joining from the other side of the world. My name is Rohan, and I'm going to talk about large language models. And this presentation will actually cover three main things. So what's attention and how it works, and the role of pre-training in making language models useful, and how scalability actually affects the performance of language models. So those are the three things that will be part of this presentation, and we're going to take a very deep dive into how each of those things work. There's going to be some math, and I'm assuming you have some knowledge in deep learning. It's still focused for beginners, but I will assume that you have like just a little bit of math and some familiarity with how linear algebra works and all that stuff. Okay, so before even starting how attention actually works and how it works, we'll take a look at the background of the current state of the LLMs. So LLMs are prevalent in our daily life. As Phillippa mentioned, she uses ChatGPT all the time, and I use ChatGPT all the time as well. And you can use ChatGPT and other language models like Gemini or Llama 3.1, which was released like 4 days ago, to do a lot of things. So you can use it for brainstorming, you can use it for language learning, you can give the model a prompt, a piece of text, and it's going to be able to generate an output for you. And if you're in the software engineering community, if you write code, you also know that GitHub Copilot is a magnificent tool. And so there are many use cases for LLMs. These are just a few. You can also ask it to solve reasoning questions. You can also ask it to help you out with your learning journey, anything that you're learning. And so these LLMs have been widely successful, and how companies usually benchmark them or evaluate them is by taking some data sets. These are like standardized data sets, and every new model that comes out, you basically evaluate these models on these benchmark data sets. And the goal of every new company or every new model is to basically surpass the performance of the previous model. And as we go on in time, newer and better models come out, and by many different companies. And you can see that after the invention of transformers, which was in 2017, we can see there's like an explosion in the number of models, and the quality of the models, they just keep getting better. So initially we just had the text version of ChatGPT. Now we can also use like multimodal versions where you can put in an image or like a PDF, and then you can interact with the model using multiple modalities. So image, videos, and text, so on and so forth. So if you go on Archive, which is a website where you can actually find preprints, and you will see that the number of papers keeps going up every day that are published on Archive. And so there's like an exponential increase in the number of papers if you just query or type in the keywords large language model or language model. And it's actually pretty difficult to keep up with the pace of the latest research. So yeah, every day newer and better models are coming out, and it's just there's like a lot of explosion in terms of the quality of the model that is being released every day and every month by these big companies. So we can actually consider all this progress that is happening in the space of LLMs, and you can pinpoint them to three main things: so architecture, pre-training, and scalability. And so this presentation is broken down into three subparts. We're going to take a look at the architecture, where we will talk about each and every block in this figure that you see here. You might have seen this figure on the internet somewhere. And so we're going to talk about how attention works and what the different components of the transformers are and how they interact with each other. We're going to see that if you want to train your own LLM, and what can you do in terms of collecting data and making sure the data is of high quality. And that would be covered in the pre-training stage. And lastly, we will see what happens when you just increase the size of the model in terms of the size of the model itself, but also with regard to the compute that you use, the amount of compute that you use, and also the amount of data that you use to train these large language models. Okay, so that's like the high-level overview of what I'm going to talk about. So without any further ado, let's talk about the architecture. I'm going to pause in between after each section to see if there are any questions, because it can get a bit overwhelming in terms of the amount of information that's present here. So even before the existence of transformers, there were some models, and they were called recurrent neural networks. You might have heard of them. and they were used for quite a long time before 2017. And the way they work is like they just take a sequence and then they generate a sequence, similar to how transformers work. But there were quite a bit of problems in terms of how RNNs actually operated. So they were really good at processing sequential data such as time series, speech data, and translation data. And translation could be if you want to translate a sentence in one language to another, and that is like a sequence. So it's really good at processing sequential data. However, there were some issues, such as the vanishing and the exploding gradient problem. And so if a sequence is very long, because you do matrix multiplication inside the model, and these models actually do matrix multiplication, and that's how they learn. If a sequence is long and extremely long, the long range context dependencies are not modeled adequately. So there's like this loss of information if you wanted to refer to some information that was seen by the model a long time ago. There is some positional information encoded. So there's like relative positional information encoded, because when you feed in a sentence to the model, you actually show the words one by one. So the model knows, okay, this word actually comes before the other word, and so on and so forth. But you don't have explicit positional information that is part of the model. So you don't directly tell the model, okay, this is the position of word number 3, or so on and so forth, something like that. And one of the biggest drawbacks of sequence models such as RNNs is that there is no parallelization, and this can lead to drastically slower training times, and it just makes the learning process of the model more inefficient. And so given that in 2024 we have so many GPUs, we just want to leverage them to the maximum, the best as we can. So we want to parallelize everything, and we want to make sure that the training is actually pretty fast, so that we don't have to like wait around for our model to be trained and actually make it useful. So how does the transformer actually address these issues? So now we're going to slowly transition into the features and the different components of the transformer, but this is a very high level overview of what the features of the transformers actually are. So there is no recurrence. There's like a block after block architecture, but there is no recurrence. And this sort of mitigates the gradient propagation issues. Also with another thing, which is called residual connections, which I'll talk about a bit later. And unlike RNNs, we actually tell the model these are the positions of the input sequence. So positional information is explicitly encoded, and we will look at one way of doing that. Attention is something that everybody has heard about, and this is one of the key inventions of the transformer architecture. And it helps to selectively focus on parts of the input and use information from parts of the input to generate the output. But one of the most important features of the transformers is that it's highly parallelizable. And so you can use multiple GPUs to train your network. I was reading this paper, the technical report for Llama 3.1, and I think they use like 16,000 GPUs, which is quite a bit. And if you're a student, you probably won't be able to do that. But that just shows you that even training a 405 billion parameter model like Llama 3, you can't just use a single GPU. You actually need multiple GPUs. And that's actually made possible because the transformer is parallelizable. Okay, so let's now jump into the different components of the transformer. So the transformer has two components, the encoder and the decoder. And inside each encoder and decoder, you have different subcomponents. Two of the crucial components of the transformer and any encoder or decoder based model is the positional encoding, which is this part, and the multi-threaded attention. I'm also going to talk about the feed-forward networks, but that's like, I will just categorize those into like the tips and tricks section. So let's start talking about the positional encoding and how we can actually encode the position of a sentence or for the words in a sentence into the model. So we're going to take a look at the example. So like I said, there is no recurrence, so we need to explicitly tell the model, okay, these are the positions of the words. And this can actually help the model learn the structure of the input. So you know that in different languages, the positions of the words actually change the meaning of the sentence and also the syntax and the grammar of the sentence. So actually helping the model understand how you can incorporate positional information will help the model to better understand the structure of the underlying language and the semantics of the input. You can use different ways to encode position, but the sine and the cosine encodings is the one that was also used in the original transformer paper. So we're gonna just discuss that. But there are other ways to encode positions. But to keep things simple, I'm only gonna talk about sine and cosine encodings today. So I'm gonna use a running example throughout this part of the presentation. So I'm gonna use a sentence. It's gonna shorten or extend. It's gonna be short and long, but it's gonna be part of the same sentence. So I have 3 words here, a fluffy blue. And the first step is to tokenize them. And by tokenizing them, we just break the sentence into individual words. And you can see if you have used Python or any other language such as C, these are like individual units of the list. So we can see that we take this sentence and we then tokenize. A token is just a unit of language. And so we have different words here or different tokens. And I'm going to use words and tokens interchangeably because in my example, it's just easy to understand that way. What we're going to do is we're going to take each token or each word here, and we will have an embedding. In this case, we have 4 numbers for each word. You can see there are 4 blocks here, 4 green blocks. And this combination of blocks is called a vector, or it's just a list of real numbers. That's what it is. And we are going to add this positional encoding to the embedding of the word. I haven't told you yet how do we actually get the positional encodings, but that's how we incorporate the positional information into the embedding. And this is what the model uses. So we can use a simple logic where for even positions, if the word is at an even position in the sentence, so you can see the letter A or the token A is at position 0, assuming indices start from 0. Fluffy is at position 1 and blue is at position 2. And so for even positions, we're going to use the sine formula, and for odd positions, we'll use the cosine formula. Okay, so let's take a look at an example. So this is the same sentence from before with an extra word here, a fluffy blue creature. And here we have the positions of the tokens. So A is 0, fluffy is 1, blue is 2, and creature is 3. And we want to create a positional vector of dimensions 4. So since the original embedding had 4 blocks, we also want to make sure that the positional encoding also has 4 numbers so that we can add them, right? Because if the dimensions mismatch, we won't be able to add them. So we're going to create a 4-dimensional vector. So there are a couple of hyperparameters we have to choose, and hyperparameters are something that the user tells the model, okay, these are the design choices that we're going to make. So we set d equals 4, and we set n equals 100, and n is just an arbitrary number, and we're going to use this formula. So this is n, so 100 is in the denominator, and we raise it to the power of 2 times I divided by the dimension of the model. And dimension of the model here is 4. And so you can see that if you plug in the numbers, so if you plug in POS, which is K here, so position, which is K here, if you plug in the numbers into this formula, you will actually get a positional vector of 4 dimensions, or d dimensions in this case. There's one more thing I need to mention, that you can see I is repeated twice here, or the value of I is repeated twice. And this is because for each word or each token, we have the sine and the cosine. So we actually need like 2 copies of that. So I ranges from 0 to d by 2 minus 1. So you can see I is 0 and 1 here. And if you just divide d by 2, which is 2, and minus 1 is like 1. So I ranges from 0 to 1 here. And so we'll do the same thing for all the words, and you will see we get a list of real numbers as the positional vector. Now that we have the positional vector, what we're going to do is we're going to add these positional vectors to the original green vector that we have. So this is the green vector. I don't have the colors here, but this is the green vector. And this is the positional vector that we got from the previous slide. And we're going to add those two. And we have the positional encoding. And that's all there is to it for the positional encoding. It's just a simple addition operation. And this tells the model, or this gives information to the model about the positions of the words. So I'm going to stop here for a couple of seconds and see if there are any questions. Let's see. I think there are no questions, so I'm going to move on. Okay. So there are different types of transformer models. The most commonly deployed model that we interact with is a decoder only model. So it doesn't have the encoder. So you have 3 categories of models. We have encoder only models. We have decoder only models, such as any kind of GPT model. So Llama is a decoder only model. And Gemini, I believe, is a decoder only model. It's like a language model which predicts the next token. ChatGPT is a decoder only model. But there are also encoder decoder models such as T5, which have both the encoder component and the decoder component. There are encoder only models which don't have the decoder. And an example of that would be BERT. So encoder only models are really good at giving you representations of any input. And by representation, I mean you take some string and it gives you a list of real numbers, and you can use those real numbers to do any kind of mathematical operations or anything like that. But a decoder only model would be useful when you want to generate the language given some input. So let's say you ask a question to ChatGPT, and when it generates the answer, 1 token by 1 token at a time, that is a decoder in action. So what we're going to do is we're going to take a look at the attention mechanism from the perspective of the encoder. And then we're going to extend that idea to the decoder, and we'll see how everything comes together. And also, I did say that we're going to take a look at attention, but we're specifically going to take a look at single-headed attention, even though it's multi-headed attention here. We're going to take a look at single-headed attention, and then we're going to extrapolate that to multi-headed attention. Okay, so this is the block where attention actually takes place. And I'm going to explain now what it is and how you can intuitively think about this attention mechanism. It's actually not that complicated once you understand, but it can get a little bit complicated to understand how it works. But the actual mechanism is not that difficult to understand. So at a very high level, what is the role of attention and what it actually does during the training process? So you can think of attention as a way to dynamically fetch relevant information from different parts of the input. And so it creates this like associations between the parts of the input, and those associations and the strength of those associations is determined by the weights of the attention mechanism. And these are called attention weights. So an example would be, like I'm showing you an example on the left here where the word it refers to the word animal or the animal. We can also see that the word or the token it refers to tired. So that's why you can see that the strength of these lines or the color of these lines are actually deeper compared to the other ones. So the other lines are sort of light in color. That means it's not strongly associated with these tokens, but they are, the word it is actually associated strongly with the word animal and tired. So it refers to animal and tired. Okay, so this slide has a little bit of math, but it's very simple math. And this is important to understand how attention actually works. Which we're gonna look in the following slides. So some preliminaries. Dot product is nothing but a measure of similarity between vectors, and you would have it's basically a summation of the element-wise multiplication between two vectors. So you have two vectors a and b. You multiply the first element of a with the first element of b, second element of a with the second element of b, and then you just sum all those up, and this will give you like one scalar value. And the higher the value, the more similar those two vectors are, and the lower the value, the more dissimilar those two vectors are. So there are also other things that were introduced in the original transformer paper. They are called the query, key, and value vectors. So I'm going to give you some intuition with regards to how you can think about these query, key, and value vectors. So think of we can think of these as retrieving information from a database. So I like to use this analogy where imagine you're at a conference and you are deciding to go to different talks in a conference, and you want to ask yourself, okay, you want to have the query or the question, what are the best talks on LLMs? And so this is your query, this is your question. And the keys would be, you just look at the talks, and what you do a dot product between the query and the key. And so you want to see how similar is your query or question to the title of the talks. And the more similar they are, the higher is the attention rate, and more is the attention you're going to pay to those talks. Because your time is limited and you want to see how you can optimize your time so that you can get the most information from all these talks. So based on how much attention you pay to each of the talks in the conference, you can basically weight your attention with the content of those talks, and that is the value vector. So the value is the content of those talks. And this is the formula that you see on the right here, a Q dot product with capital K transpose. It's just a matrix. That's why you have like this notation. But we're going to look at an example in the following slide. So I'm going to again pause here for 5 more seconds and see if there are any more questions. I don't see any questions in the chat. I'm going to count till 5. Somebody wants to speak up. If not, I'm going to move on. Okay. I'm going to move on then. So now I have a pictorial representation, and now we're going to understand how attention works. And we're actually going to do some multiplication here. So this is the same input sentence or part of the input sentence from before, a fluffy. I just have 2 words here for simplicity. And we have the original embedding of the tokens, x1 and x2. And we need to get these query vectors, key vectors, and the value vectors. And those are these vectors here. How do we get those, get these 3 vectors? We have another matrix for each of these query, key, and values. So this is called the query matrix. This is called the key matrix, and this is called the value matrix. So WQ, WK, and WV. We do a dot product between X1 and WQ to get Q1. We do the same with X2 as well. So we do a dot product between X2 and WQ to get Q2. To get the key vectors, we do the same operation, X1 dot WK to get K1, similar for K2. And for value vectors, we do the same operation again. So X1 dot WV to get V1. So now that we have QIs for each token, we're going to perform this operation. So let's perform that operation. So you can see these are the query key and value vectors that we obtained from the previous slide. We're going to do query dot key. So we're going to do query dot key. That's a query dot key. It gives us some number. We will also do query dotted with the key of the other word, because remember, you want to pay attention to different talks in the conference, and you want to do like a dot product between your question and all the titles of the talk. So we're going to also do that. And then we have some numbers as the output. What we are going to do, we're going to divide that result with this root over dk. In this case, dk is 64, so root over that is 8. We're just going to take the positive part of plus minus 8. And there's a reason for doing this. I'm going to explain that a bit later. But for now, we do that, and then we'll do a softmax. A softmax is just a way to change numbers into probabilities. So you can see for 2 words here, or 2 tokens here, if you add these 2, you get 1. So probability is between 0 and 1. So when you do softmax over many numbers, you actually get values between 0 and 1. And when you sum all those values, it actually sums to 1. What we're going to then do is we're going to multiply the result of this operation, the softmax q dot kt divided by root over dk, with the value vector. And we're going to do the same for all of the value vectors that we have. So you can see, since this has a higher attention weight, so this softmax operation gives you the attention weight. So this has like a higher attention weight compared to 0.12. That's why you see this is sort of darker in color, and this is sort of lighter in color. When we add all these VIs, so when we're going to, in this case, add V1 and V2, we're going to get Z1. And so we're going to repeat the same operation for Fluffy as well. We're going to use Q2 times K1, and we're going to also multiply Q2 times K2 and so on and so forth. And then we can perform the same operation. When we implement this, it's usually better to implement this as a matrix operation, because modern computers are designed to do matrix operations pretty efficiently. So it's just faster and you don't have to use for loops. So that is how attention works inside the transformers and under the hood. And it's basically a sequence of dot products. I'm going to see if there are any more questions, and I see a couple of things. Okay.
Just a quick question.
Yeah.
Can you hear me, Rohan?
Yes.
Yeah. So, like, why do you use softmax only? Why not um, any other neurons type of thing, like sigmoid and other stuff, like 10H and those things?
Yeah, so we can't use the tannage because it won't actually give you a number between 0 and 1. I forgot the range of tannage, but we can use sigmoid, and softmax is basically a general case of sigmoid. So if you have 2 numbers, that is basically sigmoid. But if you have multiple numbers, you use a softmax. That's the only difference. But by using a softmax, you'll get a value between 0 and 1.
So, so from your explanation, I can understand, like, it has to be in between 0 and 1. That's it. That is the reason why we use the softmax.
Yes.
And it gives the probability.
Yeah, softmax gives you the probability, yes.
Okay. Okay, thanks.
Okay. So I'm going to move on. Thank you for the question. And so if you want to think of the attention operation as a matrix, so this is what it looks like. So this is called the attention matrix. And you can see on the top, we have all the query vectors. And on the left, on the y-axis here, we have the key vectors, and we basically do a dot product. So this is the attention weights, which was just the result of this operation. Okay. And so you can see there are multiple numbers here, which is just the dot product between the query and the key values. We are going to, this is like before division by root over dk and before doing the softmax. Okay, what is the role of the root over decay, dividing by the root over decay? So it has been observed that during training, it sort of helps the training become more stable, and it sort of diffuses the information or diffuses the attention over many different vectors. And so if you can try this as an experiment on your computer where you just do this operation by taking random vectors, but you do not divide it by the root over decay. You will see that there's like this peaking effect of softmax, and that sort of results in the model concentrating on one token a lot and not really using the information from the other token. So we want to prevent that. We want to take information from multiple different parts of the input, and then we want to combine those information in some way. So dividing the attention value by this root over decay sort of mitigates that peaking effect of the softmax. So we looked at single-headed attention, and we can just take that idea and sort of replicate that, not exactly because each of these like matrices are randomly initialized. So that's why you will see people saying, or on the internet, people says like, oh, we have multi-headed attention, but that's basically single-headed attention, but replicated. And the matrices are randomly initialized. And the hope is that by randomly initializing these weight matrices, you will learn new features. And that's the only difference. And the hope is that, okay, the more heads you have, the better is the representation in terms of the complexity of how many representations you can actually learn given the input. Okay, so there are some tips and tricks that I mentioned before, where after the attention block, we have the Z matrix. We use this residual connection. You can see there's like this dotted line here that goes from the input to the output of the attention block. And this also helps prevent the vanishing gradient and the exploding gradient problem. And the long range context dependencies are also like taken care of. And you can also use this like normalization step. This also helps the training in terms of making it more stable and more efficient. And if you have some experience with implementing neural networks and using any kind of convolutional architectures, you know that there are some hidden, non-linear hidden activations in the network, so that we want to learn the non-linear features. And so for that case, we also have this like feed-forward network, where the input to the feed-forward network is the output of the add and normalize step. And then we have like multiple ReLU activations to learn the nonlinear features. And so this was one encoder block. In the original transformer, I believe we had 12 of these. So you just take this step and copy it like 11 more times. And so you have like a really deep network. Nobody really understands like what's actually happening inside these attention mechanisms. But we see that this actually helps the model to better understand the underlying language. Okay. So we looked at attention in an encoder, and you can use the resultant, or the output or the resultant output of the encoder block to do multiple different tasks. So you can use text classification. You can take the output of the encoder and classify some text, for example, positive and negative. You can also do similarity search on the internet. Let's say you want to input a question and you get an answer from a database. You can also use the representation or the output of the encoder to do a similarity search. You can also do paraphrase matching, which is a task. You can also do relation extraction, where you have two entities and you want to find the relation between the two. So there are multiple possibilities for the application of an encoder. So encoder is good if you want to get some vector representation or a numerical representation of the input. So how does the attention work for a decoder? Okay, before I move on, I'm going to see if there are more questions. I think we're doing good on time. Okay, there are no questions. I'm going to move on then. So it's very similar besides one thing, which is there was a multi-headed attention block, but now there is a masked multi-headed attention. So there is a reason for that. So when you use ChatGPT, we see ChatGPT predicts one token after another. So it predicts the tokens one by one in sequence. And when we're gonna train the decoder model, we don't want to have the future information leaking into the past. Okay, we want the model to learn what the next token would be. And while training, we want the model to learn that representation or learn that mechanism in terms of to predict the next token. We just don't want to give the future information and essentially cheat the training during the training process. And so the way we do that, so this is the same attention matrix from the encoder, but you can see there's like this mask here. And by having this mask, we can just set these values to -infinity, and that's what the masking procedure does. By setting this mask, we prevent the future information to leak into the past. And so we train the model or the decoder in a way such that it learns to predict the next token. But in case of an encoder, it basically learns what the relationship is between all the tokens of the input. But in case of a decoder, we want previous information to predict the next information. We want to take previous sentence to predict next sentence or next words. So that's why we mask the future information so it doesn't leak into the past, which would essentially be cheating for a decoder. So that's the only difference when we do attention in the decoder. For encoder decoder models, it's sort of similar, but there's only one more difference where we take the key and the value matrices from the encoder, but we use the query matrices from the decoder. So you can see the key and the values are from the encoder, but the queries are from the decoder. And we basically do the attention in the decoder. We do the masked multi-headed attention and also the multi-headed attention. And so that's the only difference between encoder, decoder, and encoder-decoder models with respect to attention. Okay, to summarize, I discussed that RNNs lack the ability to parallelly process data, and this is one of the big limitations of RNNs in terms of speeding things up during training. And self-attention is a parallel procedure, and this actually helps the user or the scientist who's actually coding the transformer architecture to leverage multiple GPUs, and it can reduce the training time significantly. And when you're actually training the decoder, you want to ensure that masking is present in order to prevent future information from leaking into the past. And if you do that, you will essentially be cheating, and we don't want to cheat while making the decoder actually learn the relationships between the input and the output. So we use a masking procedure. So that was the end of part 1 and how attention works. I'm going to pause again here for 5 more seconds and see if there are any questions. All right. No questions. So I'm going to move on to part 2, which is how do you actually make these models useful? So part 1 was the longest part, and these are sort of shorter, so it's going to be easier to understand. So if you just take an LLM and you just randomly have the weight matrices initialized with some random numbers, it's not going to be useful. And so this is an example where you have, okay, what is the capital of Canada? You just feed that question into the model. If you have an untrained model, it might not even be useful in terms of predicting the correct structure of the output. So you can see there are like random punctuations, and there's like some random word which has probably no relation to the question that you asked to the model. So randomly initialized models do not understand language, and when you pre-train them, you make the language models useful in terms of your application. So this is called a pre-training stage. And by pre-training, you would most likely get the correct answer for your question or any kind of tasks you want to do. So the model will be able to like solve your task. So you can see what is the capital of Canada, and for a pre-trained model, it will actually give you the correct answer, which is Ottawa. So I was also playing around with ChatGPT some time ago, where I just asked it a question in the sense of solving some NLP task, which was question answering. I asked it, okay, what is the best way to structure the input so that the model actually gives me the best answer? So it knows that, okay, there are different types of question and different types of question answering tasks. And for each task, you would probably need like a different prompt format. So it knows that, okay, there are different types of tasks for question answering in the domain of NLP. So this means that using pre-training, we don't need to really tune our model on new data. We could just use the model right out of the box, like the companies provide. And this sort of like gives you a quote unquote general model with multiple capabilities. Okay, so I'm gonna talk about some pre-training techniques, some strategies to pre-train these models. And I'm going to also talk about them in the context of encoder, decoder, and encoder-decoder models. So let's talk about encoder-only models, and we're going to look at two strategies to train encoder-only models. So, well, a couple of these are masked language modeling and next sentence prediction, or NSP. Masked language modeling is useful when you want the encoder to learn very good representations of the input. And the way you do that is you just take a sentence and you mask out, or you basically delete one word from the sentence, like in the middle of the sentence or the end of the sentence. It doesn't matter. And you replace that deleted word with this token, which is square brackets mask. Okay, and we want the model to unmask this mask token. So we want the model to learn what would be the word or the token that would go in place of this mask token. So the correct answer is capital here. So Paris is the capital of France. And so this objective is called masked language modeling. The second one is called next sentence prediction. And at a high level, what it does is, given two sentences, we want to see if the second sentence follows from the first one. So I have an example here. So let's say the first sentence is Paris is the capital of France. And then the sentence that follows that is Eiffel Tower is in France. So this sequence of sentences sort of makes sense. And when the model actually gets this answer correct, we want to say, okay, this is correct. And we want to set this to, or set the output of this to 1. But you can see the second sentence here, Mac is an Apple product. Sure, it's a valid sentence, but it doesn't really follow from Paris is the capital of France. So in this case, we want to assign the output as 2. And so it has been shown in the original BERT paper that if you use these two objectives, so MLM and NSP together, if you use these two together, it's actually beneficial to the model in terms of improving its performance. But there were like other models that came out later that kind of argued that NSP is not really important. So if you want to train your own encoder from scratch, I would say MLM in most cases would be enough. And in my experiments, I only use MLM and I don't use NSP. So in most cases, MLM would be enough. Okay. For a decoder, such as ChatGPT, how does the training process work and what's the objective that is used to train these kind of models? So these are language models, and we don't use masked language modeling. We just use language modeling. So you will see the only difference between MLM and just LM is that instead of masking a random token in a sentence, in case of language modeling, we just get rid of the last token. And so given some input, we just predict the final token, and the model learns to predict the last token given all the previous tokens. So this is the objective function where you have all the previous tokens till xi minus 1, and you learn to predict xi. Okay, And so let's see an example here. So today, the cleverest thinker of all time was, and you have like a probability distribution over different words. And with some strategy, you can select what would be the next word. So some people might argue you could just select the best, the token with the highest probability, which in which case you would actually predict Newton. But you might also argue, okay, jobs could also be like a good output to put here. And so there are like different sampling strategies. If you want to look it up online, the most commonly used is called nucleus sampling or top P sampling. There's also beam search. But the simplest thing, which is just taking the value of the maximum probability, that is called greedy sampling, because you just sample greedily, which is the maximum probability, or the token with the maximum probability. Okay. For an encoder-decoder model such as T5, it is similar to masked language modeling, but instead of masking one token like you would do for BERT, you just mask out spans of tokens. That's the only difference. And you train the model using an objective where you try to unmask or denoise the spans of corrupted tokens. So you can see that there's like this sentinel token. These are called sentinel tokens in the paper. And you can see there are like multiple spans which are corrupted, and you train the model in a way so that it sort of unmasks or denoises those multiple spans. So it's very similar to BERT, but the only difference is you have multiple corrupted spans or multiple masks. That's the only difference. Okay. I'm going to pause here for just a second before I move on to the data sets and see if there are many questions. I don't see any questions. We can move on. Okay. So there are multiple data sets that you can use. You could just go and scrape a lot of data from the internet, but it's probably wise to pre-process these data that you actually collected from the internet, because most of the data on the internet is not of high quality. So you want to make sure there are no duplicates and the data is like free of biases and all that stuff. And so there are some curated data sets that you can actually go and use to train your model. And these are some examples of what those data sets can be. Okay, so pre-training actually has been shown to significantly affect model performance. So you can see in the T5 paper, if you just train the model on the task that you want to solve, so not using any big data sets such as Wikipedia to sort of initialize the model or give it like a head start, not pre-train it, you can see that just training the model on these are the tasks. So squad, glue, CNN, DN, these are the tasks. So English to German and English to French, English to Romanian, these are the tasks. If you just train the model on these tasks, you would get some performance. But if you pre-train the model on a big data set such as Wikipedia or Common Crawl, you actually get a boost in performance, which is this one in bold. So pre-training actually helps the model to encode more information and makes the model better in terms of performance. If you're a company and if you want to, go out and collect your own data, it is advisable that you collect data that is diverse, and diverse data has been shown to improve model performance as well. So these are numbers from this paper that shows that, okay, as you increase the diversity of the data, so types of information that's present in the data, you get a better performance for the model. Okay, what if you have new data and you just used, I don't know, the latest version of Llama, which is 3.1, and you want to train it on your own data, and you have some hypothesis that when Llama was trained by Facebook or Meta, they did not consider your own data. Or let's say your data is like closed source, it's like very private, such as it would be in a legal setting. You want to make that model to be able to also answer questions on your data. So there is a step called fine tuning, where you take the pre-trained model and then you fine tune on your data. So this sort of mitigates the problem of adapting to new domains. So when you show the model your data or your private data, it can also help answer questions on your own data as well. So it improves downstream performance, and downstream is like just training on your own data. And sometimes when the pre-training data doesn't have some words, so the model doesn't really know what's the meaning of these words, and so providing your own private data would help the model to understand, okay, in this new data, this is the meaning of these like new words that I'm seeing right now. And so it's basically continued training procedure where you take the pre-trained model and you just continue the training process on your own data. And this is called fine-tuning. So you fine-tune the model on a new domain. Okay, to summarize part 2, pre-training actually helps the model to better understand the language and encode information into the model. And depending on the architecture of the model, you can use different training objectives such as mass language modeling or language modeling. And pre-training plus fine-tuning can boost the downstream performance of the model, and it helps the model to adapt to new domains. Okay, so that was the end of part 2. I'm going to see if there are any questions.
Hi, Rohan.
Yeah.
So I have a couple of questions. So like my first question is like, how do we pre-process the data for the models? Yeah.
Yeah. So yeah, I'm just going to answer that question and then
Yeah.
ask the second question. So one thing you can do is remove the duplicates in the data. So obviously there are going to be some duplicates in terms of the sentences if you just collect the data, if you scrape the data from the internet. And then you could also have humans go through the data and remove biases. If there are like some gender bias or something like that, you can have them remove those biases as well. You could also remove HTML tags. So I was reading the Llama 3.1 report. I just read like a couple of pages and I saw, okay, Markdown, which is like a data format, those actually lead to the detriment in the model performance. So they reduce model performance. So you also want to remove Markdown as well. But it's quite a tedious process. I wouldn't say there's like, okay, you could just run the script and your data will be clean.
And what about the information? If it is an inaccurate data, maybe the information is not correct. Like how do we process that? If it is
So the only,
trained based on like wrong data.
yeah, I mean, if you train the model on wrong data, you're probably going to get wrong outputs. And so you want to avoid that. One way to avoid that would be have someone verify the quality of the data. So Wikipedia, when you take Wikipedia, there are editors that maintain the information that is on Wikipedia, and most of the times, almost all of the times, you have like correct citations. So Wikipedia would be like an example of high quality data source. But if you just want to train your model on data that is not really publicly available on the internet, for example, medical images, you might want to consult with a medical professional and have their input in terms of the quality of the data. So yeah, I wouldn't say there's like a script you can do, and the gold standard would be to have a person to cover your data.
Okay, thank you. My second question is, what is exactly the fine tuning? So do we add the new sets of data to the training set and then we train it again, or it's still like transfer learning? Like once the model is trained and then we just use the new data for transfer learning the model, like that sort of thing. Like I didn't understand what exactly the fine tuning means here.
Yeah. So you take the pre-trained model. You don't have to add your new data to the original data set that was used. You could just continue the training procedure on your new data. So you don't train the model from scratch on the old data and the new data. You just continue the training procedure on the new data. And that's pretty much that is called fine-tuning your model to the new data.
Okay.
Yeah.
Yeah.
Okay.
Okay. Yeah. That's all from me. Yeah. Thanks.
Okay. So final part. I have like 5 minutes. I'm going to be quick. So this is the shortest part where I'm going to talk about scalability, where what happens if you just improve the size of the model using, just the number, just by increasing literally the size of the model. But also what happens if you throw more compute and if you increase the data set size that was used to train the model. So we know that over the years, the model size has kept on increasing. Llama 3.1 is 405 billion parameters. GPT-3 was 175 billion parameters. And to make these models useful, you actually require a lot of data. And also to store these models, you require a lot of storage. And this means that, okay, if you wanted to just download these big models on your machine, on your desktop or laptop, you won't be able to run those unless you have like industry level GPUs or something like that. However, there's one benefit to using such big models is that they are really capable with regards to handling multiple tasks. So as you increase the model size, the test loss decreases, and these so-called emergent abilities start to come out of these big models. So to show you an example that the test loss decreases, there's this famous paper where they introduced this notion of scaling laws, where as you increase the size of the model in terms of parameters, or if you increase the size of the data set that is used to train the model, or if you use more compute to train the model, you can see the test loss actually decreases, and that means the model generalizes better to new domains. So these are called scaling laws. And also, let me show you an example what happens if you just increase the size of this model, size of any model after a certain point. So let's say on the x-axis you have the number of parameters, and the model scale is like in terms of number of parameters. You can see after a point, there's like the sharp and unpredictable increase in the model performance. And so the sharp and unpredictable increase is called, has been named emergent properties. And you can see that, okay, this effect also holds true for multiple different models, not only GPT models, but different models as well. And this is also true when you have more compute that you use to train the model. So more floating point operations per second, which is just a metric that they use to measure compute. And you can see that the more compute you use, the better the performance of the model gets after a certain point. And this is also an example with the GPT-3 model, where on the x-axis you have the size of the GPT-3 architecture. So the architecture is constant, but you could just like modify the number of parameters. So you can see after 6.7 billion and 13 billion, there's like this drastic increase in the performance of the model. However, Microsoft released their class of 5 models, or this like collection of 5 models, where you have Phi 3 Mini, Phi 3 Mini 128K, and these like 4K and 128K is like the context length. What they found out that given the quality of the data, if you really curate your data, you're actually going to be able to achieve similar performance, such as the really large language models, such as GPT-3 175 billion, using a small model. So you can see that the x-axis is the size of the model in terms of the number of parameters in billions. And you can see that the model quality or the model performance is on the y-axis. You can see that even with smaller models, you can achieve similar performance compared to, Gemma and Llama 3, 8 billion parameters, also like Mistral. So this also is like another evidence that the quality of the data is really important. So if you read first 10 pages of the Llama 3.1 technical report, which was released 4 days ago, you will see that they actually mentioned that their performance gains did not come because of bigger models, but rather because of the quality of the data. And you will see that they actually did a lot of pre-processing with regards to ensuring the data is of really high quality. Okay, I actually came up. This is the last couple of slides. So I actually came across a paper where what they saw that based on the metric you use to evaluate your language models, the sharp and unpredictable increase in performance actually becomes predictable. So they kind of question this notion of emergence that a lot of people actually use right now. So on the left-hand column, you can see they are using a non-linear metric such as accuracy. If you're interested in why it's called non-linear, I would urge you to like go read this paper. But you can see if you use like a metric such as accuracy, where after a certain point in terms of increasing the number of parameters, you will see this like sharp and unpredictable increase. But if you use a linear metric, this sharp and unpredictable increase becomes predictable. But regardless, as you increase the model size, your performance will be better. The only drawback is that you would need a lot of GPUs and a lot of storage to actually train these models, and also a lot of data to train these models. But regardless, if you increase the size of the model, your performance will increase. Okay, to summarize part 3, large models require more data and more compute and also more storage, and it will be difficult to just run them and run inference on them on consumer hardware. And as you increase the size of the model in terms of number of parameters, compute, and the data set size, you will see these like so-called emergent abilities arise. But also there have been like some recent debates with regards to, okay, are these emergent properties actually emergent? And it could just be that the metric that are being used to evaluate these models falsely show these emergent properties that come out of these models. So if you're training your own big model or large model, it's just advisable to evaluate your model on multiple different metrics, and that would help you get a better picture of how the model performs as you increase the size of the model. And I think that's pretty much it. I know we are out of time, but if there's like one question, I'm like happy to take that.
Like, can I ask one question quickly?
Yeah, sure, go.
Yeah. So, like, how do we handle the overfitting of this model? Because as you said, like there are, if you use like large number of parameters, then the model will perform well. But at the same time, the model is kind of like overfitting the data as well. So how do we do this? And the second question is like, how do you optimize this large number of parameters? Like we can't increase it like multiple times. So like how do you optimize those number of parameters in the models?
Yeah, so for the first question, which is on overfitting, when you have a large model and when you have a large enough data set, so I'm talking about 15 trillion tokens, it's very unlikely that you would actually encounter overfitting of the data until you train it for years and years. So if you just train it for even months, you're not going to overfit on your data. And by in this case, we actually want the model to slightly overfit because we want to make sure that the model actually knows the information that is presented in the data set. So
I mean, overfit in the sense, if the training data, if it overfits also,
yeah.
in testing data, it won't be performing well. So that's what I understand the overfitting means.
Yeah, so in test data, if the test data is really out of distribution from the training data, which is not the case in case of language, because if everything is collected from the internet, it's not going to overfit on the training data because the test data is also from the same distribution, but it's from a different distribution. Let's say you train the model on text and you test it on images, obviously it's not going to perform well on images. But since the domain is the same and these models are literally trained on everything that's available on the internet, it's not going to overfit. And that's why they use what, like 16,000 GPUs to
Is it
train
also true
long
for
frequency
the
models.
small models you showed, like Phi 1, Phi 3, and those kind of models? Is it also true?
I would be cautious with regards to saying, okay, it's actually true for smaller models as well, because it's easy to overfit smaller models. But larger models, you just need a lot of data to train them. So it's
I
probably
see.
not going to overfit. Yeah.
Okay. And how do you optimize the number of parameters?
Yeah, sorry. So during pre-training, you probably won't be able to optimize a number of parameters if you're using full pre-training. But what you can do, you can reduce um, the precision. So for floating point values, you need 32 bits. You can also train the model using 16 bits, and so that would require less memory. But most of the optimization actually happens in the fine-tuning stage, where there are these things called low rank adaptations, or LoRa. You can Google LORA, and that will
Mhm.
probably give you like more information in terms of fine-tuning.
Okay. Yeah.
Yeah.
Thank you. Thank
Okay,
you
I
for your
think
presentation. Yeah. Thanks.
yeah, I think we should stop here. It's 12:08. Okay. Thanks, Anya.
Thanks, Rohan, for this great session. And I was proud to check it out at the Alberta Machine Intelligence Institute Upper Bound Conference this year. And please, I invite you to class Rohan for this excellent talk. Clasp it in the chat for us, please. And now we are going to go to our last but not least talk with our Google developer expert, Ravimba Karanjai. Hello, Ravimba. How is your day going? From where are you joining us today?
Hi, hope I'm audible. So I'm joining from Houston right now, and yes, it's a rainy day. It's going good so far.
Just one moment, please. I'm just to give you, I will to give you quick introduction to our audience. Now we are going to dive deep to one of the most rending AI applications with immersive art with generative AI and intelligent captioning with Ravimba. Ravimba Kerenjai is a full-time graduate researcher, part-time hacker, and FOSS enthusiast. He works with I2C Lab at University of Houston and Heb Binero Lab at Rice University as part of his PhD. He has previously worked with Mozilla Research, Mixed Reality Team, and IBM Research Systems Group. He is a GDE expert in web technology and machine learning, Google Champions Innovator in Cloud AI ML, an avid reader, and he loves to watch anime. Please, let's welcome our third speaker, Ravimba.
Thank you,
Now I
Vanya, for
will,
that.
yeah. Now you can share your screen. The stage is all yours.
Thank you, Vanya, for that awesome introduction. Hi, everyone. I'm sure you have a long day till now, and I'm the last speaker now. So I wanted to take a step back and talk towards more fun days about machine learning rather than going too deep about it. We are gonna go a little bit high level on what these quote unquote AI, or rather talk more about the LLMs and some of the more interesting use cases. I wanted to make this talk more interactive, but since this is online, it might be a little bit challenging. So what I want to do is that whenever I might like need some feedback from you, you might, if I ask something, okay, how many of you have done something or something, you can probably just use the raise your hand command here, and that will give me kind of more feedback from you. So hi, today I'm going to talk about immersive art and generative AI. What is immersive art and how does it pair up with generative AI? We will delve into that. Uh, so hi, I'm Rabimbo. That's my friend in the picture, what you can see. Oh, my slides are visible, right?
Yes, you haven't shared your screen yet.
Oh, actually, I did, and good thing I checked. Uh,
Yes, now we are
okay,
seeing your slide.
good thing I checked. So back to the session. So today we're going to talk about immersive art and generative AI. What does it mean? We'll talk about that a little bit. So first, that's me, and with my friend. That's before I joined my present program. So I'm a Google developer expert in AI ML, also a cloud champions innovator and a cloud research innovator. On my professional side, I'm a PhD candidate. I work mostly in the security privacy, mostly in systems. But right now, I also work in AI, or more importantly, like more precisely in LLMs. I work in like LLM safety, you can say. So I'm pretty sure you all don't need this primer, especially after the previous talk. But since I made this slide, I'll still go over that. So what is generative AI? And when I say generative AI, not AI, what is a LLM? What does it do? So as we can see, LLMs, I want to say kind of like a very, in a very high level, a very souped up prediction machine. It predicts based on what it gets as an input. What are those predictions? So for example, if you have a sentence like roses are red, what do you think comes next? Anybody has any idea? Maybe you can unmute or just write in the chat.
Violets are blue.
Okay. Anything else? Okay, why specifically that? Let me go to the next slide. Violets are blue, sugars are sweet. So I'm assuming you probably saw this slide before. But if I am like a normal human, I would say roses are red. Yes, violets are blue, rose sugar is sweet is fine. It might be anything else as well. Roses are red, something else is red, anything. But when LLMs work, they work from a very huge number of data sets from which they kind of try to make these predictions. How? LLMs let us prototype first. When we say prototype first, it's like the creativity aspect of it, or I would say the prediction aspect of it. You can use this for predicting a lot of text or predicting a lot of code, maybe if you want to write a code. Going back to the previous example, what happens here is that the data set this LLM has been trained on, the associations it has made from those specific words or tokens, it has kind of predicted that if something like roses are red is there, there's a high probability, very high probability that the next token might be violet, and the next one after violet might be R, might be blue, and the next token might be a comma, and so on and so forth. That's completely utterly based on the probability distribution on the data set it has been trained on and the architecture. It has nothing to do with that the LLM can reason. Going forward a little bit, this was all nice and fine, and we have all played with ChatGPT a lot and other uh, GPTs. But what about multimodality? So when we say multimodality, this same kind of LLMs or the transformer architecture works with multiple kinds of media. So our input sequence in the previous one was text, but that input sequence can be anything else. For example, by anything, for example, it can be audio, it can be an image, it can be a video. But how? So just here, I was talking about that, okay, these are predictions based on tokens, and it's easy to assume that token as a word. How does it work for audio? How does it work for image or even video? Any of you have played with any of the vision models or models which can produce image but also can understand image? And like what you might have played with? Oh, you can unmute. Okay, EMU model meta. Oh, nice. Anything else? So nobody played with GPT-4? So one of the most common examples here, I'm assuming a lot of you probably have tried with, is GPT-4. So GPT-4 can create images for you, understand images, even though the creation part is not directly for like GPT-4's capability, but it can understand images for you, everything. If you have played with Gemini, especially the 1.5 model, you would see that it can understand images. It can also understand videos. And then there are models where you can understand audio or try to learn from it. How this works are not all of the models work in a very similar way. Some of them actually convert these models or these different modalities to text before actually doing the prediction. For example, in case of audio, a lot of, or if you have tried with YouTube video, you will find a lot of demos to kind of understand or summarize YouTube video. A lot of them, what they do is that they do it speech to text, convert everything to a textual media, so input sequence is text, and then the GPTs work their magic on that. Uh, for some of the models, some of the vision models, that's not really the case. So they actually try to predict based on images. Not, again, when I say vision, I'm saying image. See, I'm not talking about video. Even the vision models which are capable of understanding video, more specifically the open source model called Lava and even GPT-4, how they work is that they don't actually work on the video. They capture specific frames and then try to understand those frames instead of the video. Why this is important? Because video is essentially not just combination of images. As a human, how we see a sequence of images and understand the temporal meaning between those images is not how these LLMs work. So that's something we have to kind of like keep in mind when trying to do anything with that deals with real-time audio or video. So this is kind of like a very high-level slide. So welcome to Gemini era, because Gemini now supports audio, video, and all of, and why we might be interested to learn some of its parts. So there are multiple models available inside Gemini and also the open source versions of them. So Gemini has Ultra, Pro, and Nano. So Ultra and Pro, something is we cannot run in our own devices or instances. The Pro model is famously available in, if you go to gemini.google.com and just chat with the model, mostly you will get access to the Pro model. And the Nano is part of mobile devices, or it's supposed to be part of mobile devices. If any of you is using a Pixel 8 device, specifically Pixel 8 Pro, you already have Nano enabled in your device, and the summarization, text summarization specifically in the Recorder app and others, they are done by this. This is interesting for us because the Nano model we can actually use by ourselves directly by accessing it, and we will see how we do that. The benefit of it is that your data does not go out anywhere. It's directly processed on device. So there is no chance of like policy violation if that data is very sensitive in nature. If you look at the ecosystem, the Gemini ecosystem, it can be defined into two parts. So one is for consumers, where you can just open the app, web app. It's in Gmail, Gmail's assistant. It's in everywhere right now, probably. So you can use that as a consumer. We are more interested in what you can do with Gemini models as a developer. So if you want to build some cool experiments with it, some cool applications with it, how do you kind of start? That's what we are gonna be mostly focusing on. And then if you are if you are happy with it, if you want to kind of deploy your app in a production or go forward, then there is the other part where you can deploy these models in cloud in Vertex AI workspace or in your own choice of infrastructure. We will also not go there. So we are mostly into the developer part, how you can use the API. Also, some of these, how you can use without using a dedicated API. So what about web? Since when I started the presentation, I said I'm a GD in ML and AI, but before that, I was a GD for web. since I used to work with Mozilla, Firefox is very close to my heart, and Chrome is very close to my heart. So anything that runs in web, I'm all into it. So can AI run into web? So when I say web AI is not cloud AI, there is a very subtle difference when I say it's run to web and accessing it through a website. So I'm assuming by now you all have at least experienced ChatGPT or Gemini or Claude or any of these using browsers, right? Using web pages, just chat with these models. What happens is that your text or whatever you are chatting with goes to a server where the LLMs are running, and then you get the text back, which is awesome. But wouldn't it be more awesome if you could run it directly in your machine without going through anything? Just open up your browser and that's it. You don't have to download anything, you don't have to do anything. And even if you are in a spotty connection or in a place where internet is prohibited temporarily, even then it should work. So let's look at how this whole thing works at presently and if we want to do something different with that. So this is a traditional model, how it works. So you have your AI model running in some cloud, someone's machine, or your own machine maybe. It's running in a dedicated machine, which is not where it's getting consumed. It's running in maybe using your CPU or GPU or a combination of that. And then you have your web application that all your users, your friends, or anybody who is accessing that. And that sends your calls, the API calls to the server, and you get the text back. And that's how it works. Very traditional web app architecture. What about WebXR? So here I'm going to stop again and ask, anybody has any idea what a WebXR means or have played with WebXR? You can also raise your hand. I'll just get a response. So what is WebXR? So WebXR is called XR, is Web Mixed Reality. I'm pretty sure a lot of you have already heard about Apple's Vision Pro, which came out, which is supposed to be the awesome headset that brings you to immersive reality. Before before Vision Pro came out, WebXR or people have been creating immersive applications, and these for at least a decade. So back in 2015, WebXR first specification was written, and the concept was that if you have a VR or mixed reality application, be that be augmented reality or virtual reality, and you don't need to have a dedicated machine, or you don't even need to have like a software downloaded and that actually runs those applications. So the question was, why can't we expose that in web? Why can't your browsers expose the same APIs, expose some of the capabilities of your VR devices through browser? So essentially, if you run a browser or a Chrome or a Firefox or any kind of browser in your maybe Meta headset, Oculus, or HTC Vive, or in Vision Pro, doesn't matter where you open that browser. If you have written an application, a web application that utilizes those API, all your user has to do is just open up that web page, and they will be inside a mixed reality application that can take benefits or that can leverage all the device specific APIs. That was what WebXR is supposed to be. Fast forward, right now, WebXR is being used in a lot of different places, and I'm pretty sure a lot of you already use it without knowing it. For example, this is a video of something that right now runs in all of your mobiles. If you have used Google Maps and you have seen maybe 3 years back, a new feature started coming up where it shows you live location. So if you want to see, if you press on that, it will open up your camera and it will show real time. If it will show like real time marker on real real scene that, okay, go right, go left, all those. This is what happens inside. So the AR Core API gives it access to all the depth and visual information. Based on that, WebXR or the WebXR API gives you access that, okay, go right, go left. So it brings you spatial awareness. And if you have a, I think, Android device or even Apple device, you probably can already use it in Google Maps. How are these exposed are part of two APIs called AR Core in Android and AR Kit in Apple. So with that, we first want to see that if we want to do it in real life, how you can build some of these. So what we're going to do is that we're going to use WebXR's API to create a virtual reality VR web app that's running in browser. And in the backend, we are going to use some of the information from user interaction to communicate with Gemini to get more immersive experience. So I have recorded it since I cannot show it in a live demo in front of you. So what happens is that, so this is a web application, and I'm gonna share the repository so that you can all run it in your own machine. So it's an art gallery. So we are trying to generate an art gallery. So I'm writing a long prompt inside it and I'm clicking generate. Once you click the generate, it goes back to the API, it tries to communicate with it, and then it should generate something. Maybe I should make it no, then you cannot hear the rest of the things. So what we're trying to do is that we are using the WebXR APIs to generate. Okay, so it got generated. So we gave it a specific scene. These images are generated by Gemini based on the prompt we just sent. Okay, the recording is really bad. But what happens is that when you run it in your own machine, you will be able to see when you press the info, it describes that image. How is the describe process is being worked is that when you press the describe button, it just goes into the API, sends the image as a base64 image and asks it, okay, for a description. And this scene is in VR. So if you have a headset, you can actually walk around this museum and kind of like experience this instead of seeing it in 2D. So yes, so this is how we kind of like, just as an example, how you can interact with it, how you can play with this. I'll share the demo in GitHub so that you all can kind of run it on your own machine. Be mindful, the image generation part is using something called Imagine. Imagine is under, let me share the screen. Yes. So this is what I'm using to generate these images. This is the AI image generator. So as long as you give a prompt, it can generate an image. It can do a lot more other than generating image. One thing to keep in mind that it's not part of like all the capabilities are not part of general availability. Some of them are inside preview. So for example, what I used, you will see most of them are inside general availability. So this demo you can run perfectly fine. But you can also do fine tuning, which is part of insider preview, which is not, you will be able to use immediately. So what we used in our example right now is visual captioning. You can also go ahead and implement visual question answering. So what you do look like is for your user, walk around the museum and also ask questions specifically on the image, not just captioning. So if you look at visual captioning, essentially, this is kind of the predictions we get. This is kind of the request you need to send it. So that's how we can, that's how easily we can build something like this. Going back to my original slides. So any questions till now? Because now we're going to switch gear a little bit. Okay, awesome. I can answer any other questions later as well. So this was all fine and good, but like I said, I'm very passionate about web and more passionate about browsers. And as long as these, like, even though this is awesome, I would want to have an like a experience where my users are not, or where my users are not kind of boggled by internet connection. This is awesome, this works fine, but this still needs an internet connection in the back end to kind of communicate with the server. Imagine if I was building an application for like a progressive web app, which you only need to access once, and then after every time you access it, you can kind of like open it through directly the web app and it caches in your device. That will not work pretty well with this kind of experience, because even though it caches the web app, these responses are coming from a server, so you still need internet connection, so that degrades the performance, right? So we want something which is more in line. So to kind of demonstrate, if you want to do something like this on your own, these two slides I can kind of like show that, okay, if you want to generate image, or if you want to kind of manipulate image, how you want to do it, and we are gonna go through that. So if you just open this Colab, so you can either scan this QR code, or you can just follow this link. And let me share this tab. Okay, so this is, just give me a second. Yes. Yeah. So this is how, if we want to do something and make it bigger. Yes. This is, if we want to do something similar and want to prototype it, just test beforehand. So I'm using Colab to do it. So let's first start installing the APIs so that we can play with it. Meanwhile, while it's doing that, let me go back and share what we want to cover. So this is the collab link, and so we also will cover another collab, which is manipulation. I'm not sure we'll have time for both of them, but I'll anyway want to kind of, I'll share this link as well. I'd anyway want to kind of show you how it works. So let's go back to our original one, share this tab. Okay. So we don't need to restart our runtime because we're running it in Colab. And then I need to authenticate my environment. And once I'm done with it, continue. Okay, so now I need to define which, because these are billable paid, even though it's very small. So I need to define my project, and then we start generating images. Okay. I first invoke the generation model. The latest one is 006, but somehow I lost access to it just before today. So, okay, let's start with, I'll start with a delicious state. We can do anything else as well. If you want me to run something, you can write it in the chat and I'll run it. But you can also do it on your own. Okay, that's how my stick looks like. Let's just see what it does. Okay. Yes, the stick still looks nice. Make it a little smaller, and it does come with a wine. Nice. Okay, good enough, I guess. Even though the wine bottle looks not very generic. Okay. Then we define certain functions because we want to do a lot with that. And I want to generate like a couple of images of a delicious cocktail. Let's make it bigger. Okay, so the cocktails are generated. And now we go back to describe part. So imagine that example we just saw previously, it was what? So it generated images in a museum. Yes, I am actually pretty getting pretty hungry. So we were generating images for a museum, and then we asked to describe an image. If you want to first kind of like prototype it, maybe in Colab, this is what we want to do. So we are generating images, so that works fine. Now let's load our Gemini Pro model, and then we want to generate some text content, not sending the image, just getting the text content. So steps to what are the steps to open a bar, and it's going through the steps. So concept and planning, legal, setting up the bar, operational engagement, etc., etc., etc. And then we want to make it a little bit different. What are the steps to open a bar? And to make it more readable, we are just doing it, displaying it in a markdown because we are going to use it later. So this is a step-by-step guide, and it's more readable right now. Once this is done, we also want to generate a menu for this bar. So we just ask it, provide a menu for a high-end bar, give each menu item a brief description. So this is our menu. Looks fine, but this is just a textual menu. I want to do something more. So we can kind of use them to kind of generate more things in the menu, but we also can give a very detailed context of maybe something in the menu and kind of generate it. For example, here we want to generate a pasta. Fine, good enough. But we want to generate in a very specific way. So style, subject, and background. So we define a template where we say that, okay, so this is my image prompt. So that's the delicious pasta, which automatically gets inserted here. Sketch modern apartment building, sketch the style, modern apartment building, etc., etc. How it should be look like a studio and a professional photo, and the background should look like a kitchen on a wooden surface and everything. So this gives us a very detailed prompt. This did not produce the image for us. We just rewrote it so that we can have a detailed prompt on it, and then use those prompts to kind of generate the images. So if you see all the 4 images, not all of them kind of followed exactly what we wanted, but these 2 kind of did. So wooden background, looks like a Korean bar and everything. So you can use these kind of techniques to create your own visual asset pipeline. So you can standardize this output as a JSON. Now the same things we got as kind of like a JSON. So these are the items with names and description, and okay. Oh, okay. So if you see what we did here is that this part. Okay, so this is another interesting thing. So what we did here is we asked it to generate something as a JSON, and if you look at it, anybody has any idea what went wrong with it? Or like, is it a validated like proper JSON? You will see if I go to a JSON validator, if I paste it, it will not be a valid because this part is not part of that. So anything from here is good enough, but the remaining is not. So this is another example of what can go wrong. If something like this goes wrong, like this, that why you cannot generate JSON properly just by prompting an LLM, and this is applicable for all the LLMs, then you have to do something like this. Let me share this trap. So this is function calling. What function calling is that you essentially write a piece of Python code. This example is not for JSON, but you specify functions. These are the function declarations. And when you call your LLM with something and it goes to function, it specifically uses this Python code to generate an output. So for example, there should be, these are other, I want the JSON example. Okay, here. Okay, so here, once it goes to the location tool, this location tool actually parses it and gets this output like this. So if we go here to the location tool, get location, you will see it's just defined exactly like how it should be and how it works. For JSON, you have to do something similar to get it validated JSON if the output automatically is not correct. So we go back. So that's how we can work with this. I'm not gonna do a troubleshooting right now. I think, let's go back to here. So that's fine. We generated some images and can work with that. But what about if we want to manipulate those images? In the demo, you didn't see a manipulation part, but if we want to manipulate something, we can do that. And when manipulation, what do I essentially mean is that you have an image, you change that image based on like what you want to do. So if you take this link and run it, okay, so this is the image manipulation. So what it does is that similarly, we just define dependencies, define a project, and then let me see if we have time to write. So what we will try to do here is that we'll try to take an existing image, and based on our prompts, we're trying to edit that image using Imagine. So edit an existing image based on what you want. For example, take my screenshot from this talk and say that, okay, make him wear a hat or change the background. Just writing these, can we manipulate these images? Okay, it ran. We have to set up image mask. So we have to somehow insert our image. So I'm trying to run acrad.io UI. This ran, right? Or this is still running? Hmm? Wait a minute. Okay. Yes, and that probably will not work because I don't have that model. Okay, so this is not going to work right now. So, okay, this is the example of what I was just saying, that I lost access to this model. So this uses image in like 006, and the last one we used 5. So this probably will fail. Yes, let me check. Yes. Okay, let me see if I can show you this directly into GCP, because GCP also has support for it. Okay. Do I still have access to it? So this is the same thing we were trying to do. Let me first try that if I can at all work with the model. Yes. Okay. So as you can see, things happen in live demo. Going back to my slide.
There is a question from one of our audience. She's
Yeah.
asking how much does it cost to use Gemini?
Okay. So I can actually show you. Let me show you. No, not show you by stop sharing. Where do I share the screen? Okay, so I did this before. So this is my account where I kind of like show these demos. Let me go to my billing. So yeah, so everything I have shown today till now, and including when I was trying to make these demos and everything, all together costed $2.08 till now. So you can actually kind of guess, or not guess, like you can calculate the cost it will require by going to this calculator. Not this page. Okay, so this gives you a better idea. So I was using the APIs I was using. I was using Gemini. So Gemini, if I kind of play with it, this is the cost. Assuming most of our like if your users, like if you're in your use case, you will be sending less than 128,000 context in one prompt. These are going to be kind of the cost. You will see this is pretty reasonable. But I didn't use only this. I also used Imagine. Imagine is this one for generating the images. I used only for the generation. This is kind of the cost you have. So this is the one I was trying to use right now, which I think I lost access again. But yes, so if you use for just for generation, it's 0.2. If I use it for editing, it's 0.2. There are other things you can do. Visual captioning, which that demo was using, is even less. Visual QA is similar. So these are kind of the cost you are looking at. And for most of the use cases, you will see Gemini has a lot of different models with different pricing. What I have seen is for most use cases, just using Gemini 1.5 Flash is enough for the use case. Is there any other question? Okay, I'll just go ahead. So you can just play with both of the collabs. As you have seen, for the second collab, you will have to ask for your project to be whitelisted so that you can play. It probably will take a week to do that, and then you get access for certain number of time, which I think exhausted. So with that, one of the other questions you might have is that what to use and when. Today, I talked mostly about Gemini, but that's not the only option you have. If you want to run something on your own machine, you can run it in using one of the open source models. For example, Gemma's 2 billion parameter model, 7 billion, or 30 billion parameter model. The other ones available, for example, Meta's Llama is very popular and very capable, very good. Mistral is also there. So based on I would want to say this is like a decision tree based on what you want to use, where, and you can decide what model you want to use. But remember when I said I'm also very interested in like the web and what we can do with it and everything. So that brings me back to what we can use this for anything in browser. So I want to work, or I want to have an experience where I can directly run anything in my browser. That brings me back to this. Where is it? Okay. So this is the Gemini Nano model directly running in browser. This does not use any web or any other applications. So this does not depend on any internet activity to work. This is right now directly in browser. The Gemini Nano small model is in the browser. How do we play with it? So for example, let me make this a bit bigger. Even before going to any kind of web page, I want to show how you can access it directly from your console. So for example, this is my browser console, right? So I can directly communicate with my page or any kind of browser APIs with that. So if you have Gemini Nano in your browser, you will be able to use this directly natively from your web app or even an extension. So the only thing you want to do is first you have to see that if it supports it. So Windows AI. Okay, so it gives me these capabilities. If I go inside AI, this is still in prototype stage. So this creates these sessions. I can create a text session. Is there a question? Okay, so I can create a text session. I can create like text session options and all these. These are all available inside the browser. And let's first start that what we can do with it. So I define a model, create a text session with that, and then I can pass anything I want to that model as a prompt. So can you write a poem for GDG Edmonton? If I run it and wait. Okay, so this is running directly from my browser. Nothing is going out anywhere. This is nice, but how we can use it in our own application? So for example, let me make this bigger.
Hey, John John from Alberta, Canada. Would you mind to disable your mic unless you have a question for our presenter Ravimba, please? Thank you.
Okay, so in this web app, this essentially uses this Gemini Nano model directly to question and answer. So how do we make sure that I'm not playing or I'm not sending anything to outside? So let's look at our network tab. So if anything happens, we should see it in network. So no, enough with poem. And let me try. Okay, that should not be the case. Let me make it small. Okay, that came out pretty fast. So what happened with the previous one? So this is running directly in browser without any internet connection. As you can see, nothing is going out. Then let's try this again. Why did it not work? Oh no, Haiku is not code, but yes. Why will it not work? Oh, does it not understand Haiku? Is it giving me the same code again and again? Oh, it is. Okay, that's interesting. Just give me a second. Let me restart it. Let me first go to console and see if that is okay. Unknown error, generic failures occurred. Okay. Oh, so the model is working. My web app is not working. Okay. Let me try to rewrite a code. Uh, okay. Okay, it did give me something. So this is okay. Let me see if it changes. Okay, so it is not giving me the same response. So this is working. I am a bad coder, so my code doesn't work, but Jmeter works fine. Okay, with that, let me go back. Yes. So if you want to build something on your own, you can use Gemini AI Nano, like Gemini Nano directly in your browser. This is not part of public release yet, but if you want to play with it, you can download Chrome Canary, which already has it enabled, and that's why I had to like switch to that browser to actually use it. Chrome Stable doesn't have it. Chrome Canary has it enabled under flag. If you have those flags enabled, you can actually play with it. So that's all good and fine, but once you start working with that, you also need to have a way to evaluate these services. That it doesn't produce hallucinations, or just how we saw in our own application, it doesn't produce the exact same things. These are different kind of matrices you can use. Auto SSX, SXS is already part of Vertex AI, which you can build or use to kind of evaluate the responses you are getting from the LLM. You can use this to do A/B testing on your LLM, which is if you want to use LLM for any kind of production thing, apart from just playing with it, testing is of paramount importance. In very short, how you work with it is that you submit some set of input prompts comparing two different models, maybe Gemini and Llama, or GPT, for maybe like Gemma and Mistral, something like that, or Gemma, Mistral, and Llama, and you run it, and you have your auto rater to rate them, and you see that for your specific use case, for specifically those prompts, which are good or bad. And also, have you ever received non-answers based on outdated information? For example, ask something and it goes back to says you, okay, this is this. I cannot give you a proper answer, or my knowledge is limited to that. Have you ever tried to kind of give it or ask it an information which is part of a link maybe, but it cannot access those? And have you ever tried to get like consistent outputs? For example, what I just saw in my own demo, the JSON output was not exactly JSON output. So to mitigate most of these, you can use something called, so you are a user, you have generated a model that you use can use things like agents. These agents are not essentially something anything else. These are like small Python snippets, Python codes like function calling, which does very specific tasks, which does either validation for you, either getting new data from websites. So a function might be, or a tool might be just a Python function which is your curl or URL lib to get information from a website, or something which grounds your data. So if you want to utilize a pipeline like that, you can use Model Garden to use that. So you can have function calling to extend the context of your LLM. You can use function calling for testing, evaluation, and kind of grounding your data. You can define what you want, define your own tools using function calling. How we saw, you can use them to make it more performant. So it's about mostly about developer control and flexibility. Very simple tasks are already we can do using just prompting. But if you want complex workflow, if you want a workflow that is deterministic, then you might want to look at this function calling. In a very high level, when I say function call, this is nothing fancy. This is what a day in the life of function call looks like. You have a prompt, you send it to Gemini. Gemini goes into these tools, which are essentially just small Python snippets or codes, sees that whichever is relevant, or if it at all anything is relevant, uses them. For example, if you ask it about a person by just sending a URL, it uses that code to call that REST API, get the output of that, and gets back. You can also use it for databases, if you have a RAG pipeline for document repository, or any kind of other use cases. Most of the things I talked today are available as a resource in ai.google.dev. So I would kind of encourage you to go there. You can also join the Discord, which has a lot of people who can answer your questions if you have them. Some of the things I showed today are available in these links as a documentation. So Google's Vertex AI and Cloud Platform GitHub repo has a lot of examples, a lot of notebooks you can just try and run. Some of the kind of cobbled up examples I showed today is part of my GitHub repo in GDML artifact. The two you saw today, you can access through those links. Thank you. If you have any question, I'm happy to take that. Otherwise, I am also happy to connect with you in any social platform, or if you have any questions. Thank you.
Thank you, Ravimba. That was a great talk and a very interesting demo to see how did you generate images and do some image manipulation with the models. To all people who are now, I invite you to applause and clap Ravimba for sharing his expertise with us.
Thank you
Please.
for having me.
No, it was great. Thanks for joining us, Ravimba. Well, thank you so much for this great talk again, Ravimba. Also, I want to appreciate all of our audience to joining us for this morning session. I hope that you learn from our great speakers, from Phillippa, from Rohan, and Ravimba. Thanks for joining us in this morning session, and I hope. Oh, by the way, I was almost forgetting to. Uh, One moment. Mhm. I will ask you guys to stay tuned for our upcoming announcements regarding Dead Fest Edmonton. We are planning it to do it in person because we miss so much to connecting with you. And stay tuned for upcoming announcements of Dead Fest. Do you have any Dead Fest plans for this year, Ravimba?
I think I might go to YYC.
Wow, that's a great destination. NYC as New York?
No, not NYC. So Calgary. So I have the. I
Oh,
think so. Yeah, I might go to speak there. So I have a session there, and I am building a, like new kind of like experience. So I might also give a workshop there. So yeah, if you guys are nearby, I will also apply.
we are 3 hours drive from there.
Yeah, but by nearby, I thought like about the time span.
Yeah,
Distance is fine.
yes, for sure. Well, thank you so much, guys. Stay tuned for Dead Fest. And it was great to connect with you. Now, have a great rest of your Saturday. Have a great weekend and see you soon. Thank you so
Thank
much for
you.
joining us today.
Thank you. Thank you.
Thank you.
Thank you. Bye.